All right, in this video, we're going over rational expressions. All right, here's your vocab to start with. Rational expression is simply the quotient of two polynomials. So it's one polynomial divided by another. And remember, with an expression, there's never an equal sign. Simplest form. When a rational expression's numerator and denominator are polynomials that have no common divisors or no common factors. All right, make sure you write those down. All right, first problem, simplifying a rational expression. What is x squared plus 7x plus 10 divided by x squared minus 3x minus 10 in simplest form, and state any restrictions on the variable? Now, we'll go over the stating restrictions in a moment, but the first thing that you want to do when simplifying an expression is you want to factor as much as you can. Okay, you want to factor as much as you can. So the numerator will factor into x plus 2 and x plus 5, because we know x squared can only factor into x and x, and then 10 is either 1 and 10 or 2 and 5, but we have to get it to multiply the 10 and add the 7, so 2 and 5 are our only two options. And of course, this plus sign tells you the signs in here are the same. This one tells you they're both positive. Okay, and then you want to do the same thing with the bottom. We know x can only factor into x and x. This is negative, means these are one of each. This is negative, means your larger factor is negative. Again, 10 is 1 and 10 or 2 and 5. 2 and 5 is the only one that's going to give you the 3. So the negative 5 and the positive 2. So now that we have everything factored, all right, the next step is to cancel out common factors. So if you notice, both of these x plus 2's will cancel out. Okay, since they'll cancel out, get rid of them. All right, so you divide out your common factors, so you just cancel them out. And then what you're left with is your function, is your expression in simplest form. All right, so the first thing you do is factor it, cancel out common factors, and then just simply rewrite your expression in simplest form. Now, what does this state any restrictions on the variable mean? Well, if we look here, we know that x cannot equal positive 5. Because if x equals positive 5, we're going to be dividing by 0. But this function here, this expression here is mathematically equivalent to this expression here. But what we don't see down here is this x plus 2 in the denominator. All right, well, if we set this equal to 0 and solve for x, we're going to get that x can't be negative 2. So we also have to take into account that x cannot be negative 2. All right, so when it talks about state restrictions on the variable, you have to state the ones that you can easily see in your simplified product and the ones that you can't easily see, meaning the ones that you canceled out earlier in the process. Okay, so we canceled out the x plus 2, so x can't be negative 2 as well as it can't be positive 5. Okay, because when you cancel this out, you don't technically get rid of it. You can't throw it away. You still have to take it into account and write anything that you cancel out. You have to solve for 0 and write x cannot be those numbers as well. Okay, so it can't be 5, it can't be negative 2 because we canceled out the negative 2. All right. Now let's look at multiplying rational expressions. Okay, multiplying rational expressions, the first thing you want to do again is factor everything. Okay, that's the first thing you want to do again is factor everything, because these are a lot easier to do in factored form. Okay, these are a lot easier to do in factored form. So the x squared plus 6 minus 6 goes to x plus 3x minus 2, x squared minus 5. This is 5 squared, so this is a squared minus b squared. So it's x plus 5 and x minus 5. And then this one will factor into plus 3 and plus 1. Okay? Now, since you're multiplying, this can really be like one complete fraction, and you can cancel across your multiplication sign. Right? So we can cancel the x plus 3's, and we can cancel the x minus 5's. Okay? So we're doing the same thing we just did with simplifying a rational expression. You simply factor everything, and then you cancel out common factors from the top and the bottom. Okay? Of course, you couldn't cancel them out if they were both in the bottom, but if you have the same thing in the top and the bottom, go ahead and cancel it out and get rid of it. okay? And then once you get everything canceled out, rewrite it in simplest form. Okay, so we have an x minus 2 left, we have an x plus 5 left for the top, and then in the bottom all we have left is an x plus 1. But don't forget about stating your restrictions, okay? Don't forget about stating your restrictions. We know that x cannot equal negative 1, because if you set this equal to 0 and solve for x, you're going to get negative 1. But we also have to take the x plus 3 and do the same thing. Because we canceled it out earlier, we still have to take into account what x cannot be. So set this equal to 0, solve for x, you're going to get negative 3. You have to do the same thing with the x minus 5, set it equal to 0, solve for x, and you get x equals 5. Okay? So multiplying rational expressions is really the same as simplifying rational expressions. Factor it, factor everything you can. Factor, factor, factor everything you can. And then it says divide out common factors. You can just cancel them out from the top to the bottom. Rewrite it with what's left. And then, of course, state any and all domain restrictions. Okay? Can't be 5, can't be negative 3, can't be negative 1. Okay? All right, I want you to try this one. Pause the video and try this one. All right, so the first thing you want to do is factor, factor, factor. So we have 2x minus 8. I'm just going to rewrite it. We have x squared minus 16 times x squared plus 5x plus 4 over x squared plus 8x plus 16. So factor, factor, factor. Well, here we can factor out a 2 and get x minus 4. All right, this is the difference of two squares because this is 4 squared, so this is a squared minus b squared. So it's a plus b, whoops, a plus b and a minus b times, now let's factor this one. Well, x squared can only factor into x and x. Both the signs are plus, so we know this is plus and plus. Now 4 can go to 4 and 1 or 2 and 2. Well, 2 and 2 won't give us 5, but 4 and 1 will. Now let's factor the bottom. We know it's x and x. Both signs are positive, so we know it's plus and plus. Factors of 16. Well, the only one that'll work to give you the 8 would be 4 times 4. All right, the only one that'll work would be 4 times 4. All right, now let's go start canceling stuff out. Well, that'll cancel with that. All right, this x plus 4 looks like it'll cancel with that x plus 4. That looks like about it. Looks like about it. That'll cancel. So we have a 2 over x plus 1 over, and then we have an x plus 4 squared. Okay, that looks like about all that we can get canceled out of this. Let's just double check. Okay, plus 4 plus 1, that gives us that. The 2 and the x minus 4. So that gives us that. Yep, that looks like about it. So this is what we have left. And take into account that x cannot be, well, here we can't be negative 4. Here it can't be positive 4. And of course with these it can't be negative 4 either. So there's our domain restrictions. Okay, so we have 2 times quantity x plus 1 over x plus 4 squared, and x cannot equal positive or negative 4. All right, so that's what you should have got for writing this in simplest form. Okay, moving on. Dividing rational expressions. Okay, now dividing rational expressions, there's literally only one more step that you have to do. Other than that, everything works the same. All right, so we have 2 minus x over x squared plus 2x plus 1 divided by x squared plus 3x minus 10 over x squared minus 1. Now, if you go back to when you learned how to divide fractions, you never actually divided fractions, did you? You kept the first one, you changed the division to multiplication, and then you flipped the last one upside down. Okay? what you do here as well. So we're going to have 2 minus x over x squared plus 2x plus 1 times, and then flip this one upside down. X squared minus 1 over x squared plus 3x minus 10. All right. Now, it's just simply multiplying fractions. That's all it is simply multiplying fractions. So now we got to go back to factor, factor, factor. Let's look at here. We have 2 minus x. Well, I'm picky and I like to have my x's positive. So let's factor a negative 1 out of there. So if we factor a negative 1 out, we'll have a minus 2 and a positive x. So that'll flip to x minus 2. And then the bottom will factor into x squared can just go to x and x. They're both positive, both, and then 1 can only factor into 1 and 1. And then times x squared minus 1. Well, this is technically 1 squared, so this is an a squared minus b squared. So it's a plus b and a minus b over, we know that x squared again can only go to x and x. We know we have one of each because this is negative, and we know our larger one will have to be positive. Well, the only way we can get a 3 with having a 10 would be 2 and 5, and the 5 will have to be positive. All right, so now we can just start canceling out things. Well, the x minus 2 will cancel with this one. One of these x plus 1s will cancel over here. It looks like all we can cancel. So we're going to have negative 1 times x minus 1 over x plus 1 times x plus 5. And don't forget to state your domain restrictions. X cannot equal, we canceled out an x plus 1, so set it equal to 0, solve for x. X cannot equal negative 1. We canceled out an x minus 2, set it equal to 0, solve for x. X can't equal 2. And then, of course, we still have this x plus 5 here. This x plus 1 and this x plus 1 will both be the negative 1, so we don't have to do this one again. But we still have this x plus 5 here, so x cannot equal negative 5. So this would be your final simplified answer. So really, dividing fractions is no more difficult than multiplying fractions, as long as you remember to keep, change, flip. That's the way I learned it, and I think it's easy to remember. You keep the first one, change division to multiplication, and flip the last one. And once you do that, it simply becomes a multiplication problem, which you start out by factoring. Then you cancel out common factors from the top to the bottom, and then you rewrite, and then after you finish canceling all those, you rewrite what's left and state any domain restrictions. And your restrictions are simply what x cannot be in your final version, and also you have to take into account what you canceled out. You have to set what you canceled out equal to 0 as well, and solve for x with those as well. Okay? So that's really all there is to simplifying, multiplying, and dividing rational expressions. All right? Feel free to watch this video as many times as you need to. Make sure you come to class tomorrow ready to work some problems. See you tomorrow.